we are going to be making a mechanical hand, kind of like what I have here. You can move the fingers around, and it's really simple. It's just like made out of cardboard and straw. So, oh, was everyone? I guess you can put it in chat or like unmute, whatever you're comfortable with. Was anyone able to like cut out the pieces ahead of time? Okay, I'm gonna take that as a no. That's totally okay. It's pretty easy. I managed to make this in like 2 hours, and that was like me being pretty distracted. So like you can probably make it in an hour and a half. So I guess let's kick things off. This is what you're gonna be making, like I said. And let's kick the discussion off by opening it to the floor and asking you what might motivate the need for this design. Like, why would I want to make a mechanical hand other than just for fun? Feel free to just like unmute and pop in the discussion.
Yeah, so what uses could you have for that? For me, I do a lot of work around the house fixing things, and sometimes I need to like get into places that are hard to reach, and I feel like, oh, if I just could like make a little hand I could squeeze in there, and that would be a perfect thing. Are there any other ideas people could suggest for how that would be useful?
I can talk about my background as a biomedical engineering student. So, making a prosthetic hand like this would be really useful for anyone who maybe wants a prosthetic hand due to like some injury or like birth deformity or whatever. There's also a lot of really good examples of mechanical hands or stuff similar to mechanical hands in surgical instruments. For example, there are like surgeries that require like a really small like cut, and you do like surgery in that tiny space. So you get like really tiny, basically mechanical hands like this big to do really small sutures and like cuts and stuff like that. So those are some examples if anyone else wants to weigh in.
Any other ideas? Okay, how about maybe for certain elements in an environment, like if they need to work in a really hot environment? Yes, that's excellent.
Yeah, for sure. Like people working in manufacturing or like I think even like glass blowing and stuff like that. If you don't want to like worry about hurting yourself or hurting others, you can rely on a robot hand to do that for you. It's a really good example.
Yeah, no, that's an excellent example. Other ideas? Okay, so yeah, I was thinking along the lines similar to like the hot environment. Um, I've done work in a fume hood where there's dangerous chemicals, and I've had to do manipulation, and it's hard. And you could wear gloves, but the gloves sometimes are kind of bulky and stuff. So having like some other hand that would be very dexterous and able to have fine motion would be helpful as well. Um, so I guess we're good to move on to the next topic. What's the next topic?
Okay, so I'm going to be sharing my screen and we're going to go over the video of someone making this prosthetic hand. It is a BuzzFeed video. Let me drop the link in chat so if anyone wants to like reference it while you build your own hand, you can. It's like 2 minutes. Okay, let me share my screen so we can watch it. Oh, Steve, I think you're the host. So I think you have to share it. Or like give me permission to.
Yeah, I'm gonna make you the host. I hadn't realized that. How do I do that though? Um, Back to participants, more, make host. All right, you're the host.
Awesome. Okay, so I'm going to share the video with you. And I'm going to pause it every now and then to like, because like the video goes a little fast. So I'm going to pause it and like tell you when I made the hand, like where I had a bit of a difficult time. Okay, so these are the shapes you're cutting out. Let me go back a little. Um, these pieces here, these rectangular pieces, they're optional, but they do help make the design a little sturdier. So like if you don't want to cut through cardboard or whatever, you can definitely like leave this out. Um, what might help is to make sure this smaller rectangular piece is about the same length longwise as this here, because this will become this part right here, the handle that you hold on to help control the string. And here we are, she's creasing the fingers at the joints. Let me use my, yeah, here's the example I made that's like half finished. You want to like crease the joints, crease the cardboard in the joints where you would fold the fingers, so you don't have to put too much strain on the cardboard pulling it down. So in this design, they use the straw, the plastic straw and string as like tendons and connective tissue, basically mimicking what like a real human hand would work like, and gives you something to pull onto to like make the hand move. So hopefully all of these materials are stuff you have at home. If not, I encourage you to think creatively about what you could use instead. For example, if you don't have string, maybe like rubber bands. Like how would that change the hand you make? Would that work the same, or like maybe that'll add a few different properties? Like go ahead and be creative, because there's a lot of like stuff you can do with this.
Sophia, I have a question.
Yeah.
Um, do you mind pausing it for a while? So I see all the fingers are pretty similar in that they have like the straws going down this one side. This is like the palm side, right? That's
Yeah.
shown. All right. But the thumb has some other interesting thing going on. Could you talk about what's going on with that?
Yeah. Let me stop sharing for a sec. So, let me find my hand. Okay. So, when you like look at your hand here, all of these fingers bend the same way. They just move straight down, right? So like that gets echoed in this design where you just pull straight down with the string. But when you move your thumb, it doesn't go down, it goes to the side. And that's what gave us like such a big evolutionary advantage, right? When like primates were evolving, because like with the thumb we can grab things. So in this design, they get around that by using the bendy parts of the straws and feeding it through the cardboard and around to create that kind of grip effect. So you can move the thumb like kind of sideways rather than straight down. It's a little tricky. The video does an okay job at like showing that in better detail than like what I can show you on like my Zoom window. But yeah, does that help?
Yeah, thanks, Sophia.
Okay. Let me get back to the video.
So, Sophia, could you explain why did they do that big piece in the back?
Oh, that's a really good question. Okay, I think I'm gonna stop the video here because that's basically all you need to know about making it. But that kind of leads nicely into our next discussion topic, which is ways we could potentially improve this design. So when I first made my hand, it worked out really well until maybe the fourth or fifth time I worked with it, which is when it started bending. You can see the crease here. It started bending forward a bit because I was putting so much pressure on the cardboard repeatedly going like this. So you can add like a little supportive piece to the back to stop it from creasing so much. And that's one example of like a modification you can do to keep your design a little more stable.
Cool, thanks.
Does the video I showed make sense to everyone? Or if it doesn't make sense, do you think you could like sort of replicate this design on your own? Groovy. Thank you, Abby. Okay, awesome. I'm glad to hear that. So, what we are going to be asking you guys to do is design this hand or toggle this hand's design around 4 design criterion. Do you want to? Here, I can put those in the chat.
Yeah, actually, if you make me the host again, I have one slide I did just to do that. Just one slide, but let's see. Okay, so let's see. Here we go. And it's this, I'm gonna go over to here. All right. So, and then slideshow, present from current slide. Okay. So here's the thing. So there's 4 criteria, and one is aesthetics. Is it pleasing? So Sophia showed you a basic design, and we want everyone to do this basic design, so just so you get familiar with how mechanical hand works. But then you're free to modify and come up with something better. And that better thing may be something that's prettier. So you may decorate it, you could color it, you could make a different type of design. And so it looks really pretty or really cool. So aesthetics is one criteria. Another one is ease of use. So I showed down here in this design, oops, it has a hand with just like, it's just one thing. You pull it and all the fingers close. So you don't have, well, I guess that was in yours too, Sophia, or was it each individual finger? I
What'd
can't
you say?
remember.
Sorry.
Is yours like each finger controls it?
Yeah, each finger individually.
Right. So it depends on what you mean ease of use. So in this one, like you just pull one thing down and everything closes. So it's kind of flexible in how we're going to determine that ease of use. But if it's something where it's like, you need a couple hands and you need like maybe a partner to help hold it, that's not going to be easy to use. So it's going to be very straightforward and very natural. So that's another criteria that we'll use to judge the hands. And dexterity will be, can it pick up something small like a paper clip, and could it pick up something bigger like, I don't know, maybe uh, an eraser, a blackboard eraser, whiteboard eraser, or a book or something. Um, and then finally, its capacity to do work. We're going to see who could lift up the heaviest object. So those are going to be the 4 criteria, and it's going to be, you could design for any one of those, or you could design for several of them. And then when we're done next week, we'll have a review of the hands and try and determine which ones are best for each of these categories. Um, Sophie, is there anything else I should add, or do you think that was covering it?
I think you covered up pretty much everything. I think we still have about 12 minutes left till we wrap up. Do you guys want to try to brainstorm ways you might want to like change this design and make it a little better? I have a few ideas to kick us off if no one wants to start, but I figured we could open it up to the floor now. Because I find that like when I'm trying to like solve a problem, it helps to like talk about it with other people rather than try to work in a bubble.
So, and again, I just want to clarify. So we want everyone to do this design first, so you get a feel for the hand, and then you come up with your own thing, and it could be completely different. So I have this object here that I got to. This is my helping hand here, right? This is to get things from like a high place because I'm short, and it goes like this, right? I grab stuff. It's got 2 fingers, so it's not the best, but it helps make it ajar if it's in a high location. So that's so the idea being that you don't have to constrain yourself to like what constitutes a hand. A hand could be very broad. So so yeah, so what ideas do people have about I'm gonna stop sharing now. Or should I go into like a little bit of the physics or we well sure I'll do that. So the basic gist is that we're doing torques. And for a torque you need a pivot and then there's something called a moment or moment arm and a force. And for a finger, it's what's called a class 3 type of lever, where the pivot is the joint, the muscle applies an effort, and the load is lifted at the end. And as long as you have that, you get something that bends. And what happens with the hand is the reason you have it out of cardboard is because it has to restore. If it wasn't out of a material like cardboard, if it was just made out of paper, it would bend and then it would stay bent. So there has to be something that pulls it backwards. So if you want to use a different material, you may want to have a rubber band in the back that's gonna like open it. Once you close it, it opens on its own, or a spring, or something else like that. But these are the basic components. You need a pivot at a joint, a place where a string or muscle attaches, and the load. So that's basically it. And I'll stop my share if I could figure out how to stop my share there. So ideas?
Well, I can talk about one problem I noticed with the cardboard hand design when I made it. So I noticed that pulling each string, after a while, it kind of hurts my hands to do, like pulling the string to make the cardboard bend like so many times. So one idea I had was to cut like halfway through each like joint here. So I'm bending less cardboard with each move, to make it a little easier to bend each finger. That's one idea I had that I'm probably gonna work out with the new hand here because the other one's getting a little beat up.
So the idea was that you're using a lot of force to bend the cardboard itself. So if you cut it, then there's less of a resistant force. Okay,
Yeah, exactly.
cool.
I'm also considering maybe not doing cardboard at all and potentially using the like, like the thinner cardboard that like cereal boxes use, because that'll be a really light and easy hands to move that like it might be a little weaker because it's thinner, but I think it'll also be a lot more dexterous because it'll take less effort to move. Does anyone want to spitball some ideas? This isn't a lecture. I'm not going to like call on anyone, but if anyone has any ideas, it'd be cool to hear them.
I mean, when I saw the prompt on the website, I thought about using pneumatics, but I realized that's probably overdoing it.
Ooh, no, pneumatics would be a really interesting idea.
Okay, because I got a box of them lying around, and
I think maybe we could add like another criteria to that list, which would be like innovation. Like that's a real awesome thing. So yeah, try the pneumatics.
Okay, so I'm not I don't have like a super strong mechanical engineering background. I only vaguely know what pneumatics are, so like would you mind like elaborating how you would use that? Because I'm very interested in that idea.
yeah, so you just have to have it so that the fingers naturally stay closed, and it would use the pneumatics at joints to keep it stay open, like how like backhoes and stuff work, or like any sort of mechanical arm. Like it's like hydraulics, just has like a little less power. So
And
That's really cool.
and you said Sage, you said you have some materials, maybe like some syringes and tubing or something like that.
yeah, I just have the hydraulic like tubing and the like the pipes and stuff, which they're a bit big, but they might still work. It would have a lot of strength, but not a lot of dexterity if I used that.
That's really cool. Yeah, please do that. That'd be awesome. That'd be a
Yeah.
nice.
That means you'd probably want to change the material you make the hand out of, right? Because like I feel like that would add a lot of weight.
I mean, I could make it metal, but then after that, it's just this is basically just like a arm of like a machine or something. But
Yeah, which could also be cool, but I think this thing is running for like 10 days and I
I
don't want to like
know, yeah.
So the material I would think like, so I was thinking of popsicle sticks, which is
Mm,
I think you could do that with the pneumatics. Um, and depending on how big, I don't know how big your system is. I mean, you could maybe do like PVC tubes if you have like a PVC cutter or something like that, and get
Yeah.
like the skinny PVC tubes. But the first thing that came to my mind before I saw the video that Sophia showed me was, well, I'll get some popsicle sticks because I have those lying around, and um, so you may want to do like a more rigid material. The metal I think will be challenging um, because you probably want to get pieces that are already cut, and I don't know, but it's up to you. Other ideas? So the pneumatics I think would also do for, or the yeah, pneumatics you're talking about would do for strength, and if you want you could do like hydraulics and put like water in there and see, and that would also make it strong. um what about some of the other categories like dexterity, picking up something small versus picking up something big? Any ideas for how to make a hand that gets that ability to those do those different sizes?
I mean, you just have to make the tips of the fingers small enough to like get it, because you could still have them be pretty precise. It would just have to be whatever's connected to it pretty small, I guess.
Abby, I think I saw you unmute yourself. Do you want to did I cut you off or anything?
Oh no. I was just saying, since the for you know how they put the support and you put the support in the back.
Right.
Oh, sorry about that, dog. Um, maybe instead of putting a support in the back, you could bend the whole arm so it kind of um let me like like bend it like this,
Oh,
so like you wouldn't have to put like the extra one in the back. It won't.
that's an
It won't.
interesting idea.
Yeah. It won't. Wrong one. Sorry. It won't put a lot of. It won't help too much for dexterity, but just with like the cardboard.
Yeah, you would be really doing a good job working with like the starting material that we're working with.
So it's interesting because you gave us ideas for more criteria to add. So another important thing with engineering in practice is you want to try to limit how much material you use because we want to make things more green, so we don't waste as much
Cost
material.
effective.
Yeah, and we want to make it more cost effective. So if we find a way to take material and limit the amount of material we use, then that's great. So that's um, another criteria that we could consider is like, could you do a lot with a limited amount of material? What's that called? Efficiency or something, Sophia?
Yes, yeah, something like that.
Yeah,
Yeah, or cost effectiveness, I guess.
yeah.
So we have about 3 minutes left. I don't want to like keep you guys too late, but the conversation we just had is a really good example of what goes on in pretty much every engineering conversation. You know, like you have like the first iteration of something and it's not perfect. It's like the 1.0 version. And you go into a conversation with someone and say, here are the problems we have, and here's the purpose we need it to fill. The purpose in this like project, I guess, would be the design criteria I put in chat. But we have a flawed initial design and we are working in groups or solo or in pairs or whatever to figure out how we can meet those design criteria and not and like fix any of the problems that we find on the way. That's pretty much what engineering is. It's just fixing problems we find on the way. Um, Sometimes it's fun, sometimes it's difficult, but it always ends up with a product you don't expect. Um, so before you guys head out, I just want to remind everyone of the resources that are available to you. So I don't know if you guys have Slack. I don't know if that's like something like high schools use right now, but we do have a Slack that you guys can join. Slack is like a messaging service.
Sometimes people are more familiar with Discord.
Yeah, it's basically like Discord, but like professional. You can make an account and join it. I just put the link in chat, and there's someone on Slack pretty much all the time. So if you need like advice or questions, or if you just want to talk to someone about your design, come on, hop in. Everyone's super nice. We also have the SWE UMass Gmail, which is swe.umass@gmail.com. Feel free to shoot us an email if you have a question. And we also have office hours. So like I'm running an office hours. There's like other ladies in the Society of Women Engineers who host open Zoom hours, kind of like this, but like, it's kind of like one-on-one. And you can hop into one of those Zooms literally anytime they're live. I believe there's a list of everyone's Zoom hours on the Women in Engineering and Computer Science website that you can find. But if you're up against like an obstacle that you can't figure out, don't work in a bubble, because I used to do that a lot and it's maddening. Like if you have a problem, reach out, because it'll make everything easier for everyone.
So Abby and Sage, do you know where to find the schedule for the Women in Engineering and Computer Science extravaganza?
Yeah.
Okay. All right.
I was a bit confused on the actual platform, like the hop in to or whatever. Since I wasn't sure how to actually access this Zoom meeting off of that, I had to go on to the actual like PDF of the paper.
Yeah, so the hop into and the Zoom are different. And so Sophie, you put the link for the website with all the activities, right?
Yep.
So the link that Sophia put in has all the activities and the drop-in sessions for SWE, which are really awesome. I advise people to check that out. But the hop into is you have to go to hopin dot to, right? And then you set up an account. And once you set up an account, you put in your name, you put an email, and then you have an account. The next thing you need to do is search for Women in Engineering extravaganza, and it'll show up. Right? When you do that search and like search for events, and you have to click on that and buy a ticket, and then it'll send you the link to get in. And so, I mean, I could briefly show that to people if people want. I'll show you. I could show you what it looks like. Should I do that, or are we good?
Sure, you could.
All right, so let me see if I can find it. So,
I have it up now if you want to like give me permission to share.
yeah, okay, sorry about that.
No worries.
Thanks, Sophia. How do I make course? Okay, you're good, I think.
Yeah, Hopin's kind of weird, but once you figure it out, it's pretty easy. Can anyone? Okay, can you see? Okay, so I made an account to register for this event on Hopin too. The ticket is free, so don't worry about like having to pay or anything like that. This is the front page. You have chat here. And on the side, or like once you scroll down here, there's all these other like little events you can go into. Like this links to the UMass BME page. You love it. These all link to different like UMass sites that you can check out. On the side we have the stage, which would be like where our speakers would be if we have anyone speaking at the moment. And then in Expo is kind of like a lot of the little like side booths. Like here we have like all these little like engineering organizations, engineering majors, stuff like that. Other resources you can like get in contact with. So this is primarily for just like finding resources. I think this is primarily just being used for the stage section where like everyone can come in and like watch a presentation or a speaker or something like that.
So Sophia, I think like what we're doing for a lot of the times it's just gonna be for the expo. So the videos like this video is gonna be recorded and then we'll put it up on an expo so people could check it out later. And all the sessions, panel sessions are gonna be as expos. So and they're in this section and you click on it. Maybe you could show what happens when you click on an expo.
Yeah. Yeah. UMass Engineering Diversity. See what happens.
That's our expo. It's terrible. It's just a slideshow.
It's a slideshow. Yeah, there's some people who made videos. There's some people that made slideshows. Yeah, so it kind of runs you through like some of the basics. Okay. Yeah, so this is definitely like a good thing to check out on your own, probably. Look around and see what UMass has.
Yeah, there's some good videos done by other teams and groups.
Yeah, I think
Um,
SWE might have a video. Did I miss it?
is it alphabetical?
Oh my gosh. Oh, there we are. Okay. Yeah, we have a video. Okay. I won't make y'all sit through the video, but it's definitely there if you want to check it out. I'll stop sharing.
Yeah, so that's how Hopin works. It's you check out these videos and presentations that were done, and any sessions that we run through Zoom, we're gonna put in Hopin too. So that's the reason that we have it up there. So it's always there as opposed to the Zoom. If you can't make the session, then you miss it in Zoom. So a
Yeah,
lot
so
of
if
people.
anyone shows up late or misses it, you
Yeah.
can watch the recording.
Any other questions?
Okay, well that's basically all we had planned for you. I am going to stick around for a little bit if anyone has questions, but if not, then like y'all can head out. This isn't a lecture. I'm not going to keep you here and like make you do homework or whatever, but we'll have like check-ins every now and then, either virtually or through like office hours or anything like that. So if you want to like get feedback on any design choices you're making or ideas or anything like that, definitely feel free to contact all the resources you have available to you.
Oh, one thing. Did you two sign up for the competition? The reason that's important is so that we have your emails and we could send you information.
Yeah.
Okay. And Abby, what about you? All right. So hopefully Abby.
Oh,
Oh, Abby said
okay.
oh,
I think so.
That's
I'm most certain.
okay. All right. Cool. Um. So maybe you could put your email here just in case, and we'll make sure we have that in there. I'm gonna stop the recording now. Here we go. Pause. Stop.